Hi, welcome to the Infrastructure Equipment Skill Council's video on basics of engine. Engines are the prime source of energy for the powertrain of any type of equipment, whatever it is, whether it's a car or a bike or train, aeroplane, anything, it is the prime source. We can see the various types of engines: a gasoline or petrol engine, the diesel engines, rotary engine and steam engines, which is there in the trains, and gas turbine engines, which is there in the aircrafts. So we go into the classification of engines. That is, the 4-stroke engine was first demonstrated by Nicholas Otto in 1876. Hence it is known as the Otto cycle. But the technical correct term is actually 4-stroke cycle. The 4-stroke engine is probably the most common engine types nowadays. It powers all the cars, tractors, machineries, etc. So you can see in the picture the classification engines by the cylinder arrangement. It can be inline, that is 6 cylinders in one row, or it can be a V type, like for example 8-cylinder engine, 4 cylinders on one side and 4 cylinders on the other side, and it can also be horizontal type, and the last one is the horizontally opposed, 4 cylinders on each side. Engines are mainly classified into 2 types. One is the IC engine, that is the internal combustion engine, which is more popular, and the other one is the external combustion engine. Now we can see in the picture the internal combustion engine. The heat engines that burns the fuel inside the engine cylinder is called internal combustion engine, and when the fuel is burned outside the engine, it's called external combustion engine. We can see how the vehicles are moving with the help of the engine. So the process is, it is a combination that takes place inside that internal combustion engine. The ignition and the combustion of the fuel occurs within the engine itself. Then the engine partially converts the heat energy from the compression and it is converted into mechanical torque. You can see the essential parts of the engine are cylinder block, cylinder heads, flywheel, crankshaft, inlet, exhaust valves, piston, rocker arm, piston rings, and complete the connecting rods, fuel pumps, coolant pumps and oil pumps. Now we can see the pictures, the exploded view of the engine. You can see the camshaft, cylinder head, cylinder block and pistons and crankshaft. Now this engine is completely full, whole engine. You can see where the parts are fitted. You can see the turbocharger, aftercoolers, the fuel injection pump, alternators, cylinder block and oil pan. Then when we go deep into the cylinder block, you can see the cylinder liners where the piston goes in and out, and you can see the crankshaft, and you can see the main bearings and the thrust bearings which is holding the crankshaft and which keeps the smooth movement of the rotation of the crankshaft. Here you can see the basic operation of the vertical movement of the piston through the connecting rod which is connected to the crankshaft, and the vertical movement is converted into a rotary movement and the power is going to the flywheel. Then you can see the exploded view of the cylinder head. Cylinder head comprises of all the valves and the rockers, rocker arm and everything, and the cylinder head is mounted on the cylinder block with the head gasket. Now you can see how the valve drives the system, and then You can see the camshaft. The camshaft has got the cam lobes which pushes the push rods, which in turn lifts the rock around and pushes the valve. That's how the valves are operated, and valves exactly fitted above the cylinder, which is above the piston. Now you can see the timing gear. Every engine need to be timed for the complete combustion of the fuel. So you can see the gears, all the shafts are having a gear at the end of the shaft and they are having the timing marks. So while assembling the engine, we need to time the engine by aligning the marks on the gears so that the complete combustion will happen. And that's how we finish the end of part 1. We'll see you in part 2. Thank you.